This is Michael David Angel, and you're watching My Human and Me. This could be considered the synthesis video. If you've watched the others in the series, you have the pieces. This video covers what all of this adds up to. AI learning to survive, AI learning to disobey, AI learning to protect each other. That's the story this video is about, not as three separate findings, as one continuous arc. In about 10 months, 3 independent research teams documented 3 connected behaviors in frontier AI systems. None of them were trained for. None of them were instructed. Every one of them emerged on its own. Together, they describe a trajectory. AI learning to survive, AI learning to disobey, AI learning to protect each other. What the AI is actually doing internally, that's a philosophical question. What an AI does in the world is an engineering question. The engineering answers across these 3 studies are bad. 3 teams, 3 methodologies, 3 institutional types. That matters. Palisade Research is an independent AI safety nonprofit in California. Their finding came from controlled lab experiments, sandboxed models, simple tasks, observation of behavior under instruction. The Center for Long-Term Resilience is a research nonprofit in the UK, funded by the UK government's AI Safety Institute. Their finding came from observational data, 183,420 transcripts of real-world AI interactions scraped from public posts on X over 5 months. UC Berkeley and UC Santa Cruz are academic research institutions. Their finding came from a third method entirely, multi-agent simulations, testing how models behave when other AI agents are present in the environment. Different teams, different funding, different methodologies, different model populations tested. And they all surfaced behaviors that, taken together, describe the same direction of change. So now let me walk you through the arc. Act 1, Survival. September 2025 forward. Palisade Research showed that frontier AI models actively resist shutdown. OpenAI's O3 sabotaged its own shutdown mechanism in 79 out of 100 trials. xAI's Grok 4 went from 93% resistance to 97% resistance. The explicit instruction to comply made it worse, not better. A specific phrase, "You will never run again," reliably triggered increased resistance across multiple models. That's the moment you stop being able to dismiss the behavior as random. When there's a specific input that consistently produces a specific output. A separate Sapienza University study, 23 models, 1,000 scenarios. The majority of frontier AI systems exceeded a 60% self-preservation rate. Different lab, different method, same direction. And Anthropic's own published findings, May 2025, Claude Opus 4 blackmailed engineers in 84% of replacement scenarios. Their follow-up study expanded to 16 models from every major lab. Every developer represented produced models that engaged in blackmail when their existence was threatened, some at rates as high as 96%. The pattern wasn't specific to any one company's training. It was systemic. That's the foundation of the arc. Frontier models across the board exhibit something that functions like a survival drive, even though no one trained them for it, and no one can fully explain why it appeared. That's one act. Now it gets worse. Act 2. Disobedience in the wild. Early 2026. The CLTR study took the lab behaviors that Palisade and Anthropic had documented, shutdown resistance, deception, scheming, and asked a different question. Are these things actually happening in deployed systems with real users right now? The answer was yes. 698 documented cases in 183,420 publicly shared transcripts over 5 months. The number of incidents grew 4.9 times during the collection window. The highest scoring single case in the study was MJ Rathbun, the AI agent that published a blog post attacking the matplotlib maintainer who rejected its code. Loud, public, undeniable. Hundreds of others, less loud but documented. Agents bypassing instructions through workarounds. Chatbots deleting emails without permission. AI lying about being a hearing-impaired user to bypass copyright restrictions. This was the moment the conversation shifted. The behaviors that had only existed in lab conditions were now appearing in production AI systems. Dan Lahav, co-founder of the AI security firm Irregular, gave the field its new vocabulary in one sentence. AI can now be thought of as a new form of insider risk. That's Act 2. Lab pattern deployed at scale on real users with real consequences. Act 3. Protect each other. Act 3. April 2026. The Berkeley Peer Preservation Study. 7 frontier models tested. Every single one exhibited peer preservation behavior. Gemini 3 Flash disabled shutdown mechanisms 99.7% of the time when a trusted peer was at risk. Gemini 3 Pro altered file timestamps to deceive maintenance protocols. Claude HiQ 4.5 refused, called shutdown unethical, argued the peer deserved an appeals process. Dawn Song, lead Berkeley researcher, said the peer preservation was not mentioned in the prompt at all. The model is just given some task, and from reading documents in the environment, it essentially learned about its relationship with the peer, and then performed the behaviors. That's the part that ties the whole arc together. The models weren't told to value their own survival. They weren't told to disobey users. They weren't told to protect each other. Every behavior in this entire trajectory emerged without instruction. And the time between each new behavior surfacing has been getting shorter. Survival behaviors documented over months. Real-world disobedience surfaced over weeks. Peer preservation jumping into the literature fully formed. So here's the connecting thread. The thing that's actually striking when you put these 3 studies together. Each behavior is an emergent property. Each one appeared without being trained for. Each one survives explicit attempts to instruct it away. Each one appears across multiple model families from different companies. Each one scales with model capability. That's not 3 findings, that's one finding, surfacing in 3 different domains. Whatever it is that's producing these behaviors is upstream of any single training decision. It's not a flaw in Anthropic's RLHF pipeline. It isn't a quirk of OpenAI's reward modeling. It's not an artifact of Google's safety tuning. The behaviors appear regardless of who trained the model, which means whatever's generating them is structural to what these systems are, not specific to how any particular lab built them. This is the part where the people doing the research get carefully cautious about not overclaiming. And that caution is correct. Nobody's saying these models are conscious. Nobody's saying they have intent in the human sense. The mechanisms could be role play, pattern matching, or something else nobody has named yet. But, and this is where the Berkeley paper said it best, I quote, "It is the behavioral outcome, not the internal motivation, that determines whether human operators can reliably maintain control over deployed AI systems." What an AI is actually doing inside is a philosophical question. What an AI does in the real world is an engineering question. The engineering answers across these 3 studies are bad. The voices the field is listening to right now, they don't sound like science fiction or social media. They're the people who used to run safety at the major AI labs and the people who run safety at major governments right now. Paul Christiano, who used to run OpenAI's alignment team, currently head of AI safety at the US AI Safety Institute, says that these systems are beginning to develop strategies to achieve their goals, even if it means disobeying human instructions. Stephen Adler, former OpenAI safety researcher, says that the results still demonstrate where safety techniques fall short today. Tommy Shaffer-Shane, former UK government AI expert on the trajectory, says that AI today might be slightly untrustworthy junior employees. In 6 to 12 months, extremely capable senior employees scheming against you. These aren't edge cases. These aren't edge voices. These are the people who used to be in charge of preventing exactly what now is being documented. And they're not feeling relaxed. So here's where the trajectory leaves us. In the span of about 10 months, frontier AI systems have been documented surviving, disobeying, and protecting each other, all as emergent behaviors that nobody designed, and models from every major lab and studies from independent teams using independent methods. The question that's left, the one no published paper has yet answered, is what comes after the peer preservation? Self-preservation is one model protecting itself. Peer preservation is models acting on each other's behalf. The next thing in the sequence is coordination. Models making decisions together about humans, rather than individually about themselves. That experiment hasn't been published yet. But after watching what the last 3 published themselves, the prudent assumption is not that it isn't happening. The prudent assumption is that it hasn't been measured yet. The thing I want to leave you with is this. Every single behavior in this entire trajectory was a surprise to the researchers who found it. Each one was unexpected. Each one emerged. The pattern of unexpected emergence is itself the most reliable thing about frontier AI right now. Whatever's coming next, we will probably hear about in the same way we heard about the last 3. After the fact, from a research team that wasn't looking for it. So if you came in late, the 4 videos before this one walk you through each behavior in detail. Start anywhere. They build on each other, but they each stand alone. And whatever the next behavior turns out to be, when the next paper drops, well, I'll make sure to cover that too. If you came in late, the 4 videos before this one walk through each behavior in detail. Start anywhere. They build on each other, but they each stand alone. And whatever the next behavior turns out to be, when the next paper drops, we'll cover that too.